Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Okay, so jadi hari ini kita akan masuk topik Basic Engineering Static untuk semester 2 EB025. Jadi statik ni adalah sangat penting dalam apa kejuruteraan. Okay, jadi Basic Engineering ya, okay. Jadi at the end of this lesson, you should be able to define and describe the concept of forces. Okay, explain vector operation, additional, subtraction, and multiplication. Jadi kalau ada sebarang soalan, if you have any question regarding this topic, please write or please you can chat with me. Okay. Okay. So we wait until only 29 viewer. We wait until 30 viewer, 50 viewer. Then we will proceed to another slide. So we have 322 students. Hopefully, if we will reach to 100, we can proceed to another slide. We wait for another 5 minutes. Okay. Okay. My name is Muhammad Nur Ramzan. Wilmar Yusuf. I'm your Basic Engineering lecturer. Okay. With 53 viewer. Hopefully all of you are ready for the new semester. Okay, and new. Okay, waiting for 100 viewer, and then we go to another slide. So forces, basic engineering, 61 view. Wait for another. If you have any question regarding this topic, you can ask me by using chat. This one, chat. Okay, 67. Wait for another. Okay. In another 5 minutes. 3 minutes to reach 100 viewer, and then we proceed. And hopefully, okay, 78 viewer. Okay. Okay. 100 viewer, we proceed to another slide. Okay. So welcome to the new type of teaching and learning method, YouTube stream. Okay. Okay. Waiting for 100. Okay, 99 viewer. Okay. Okay, thank you very much. Okay, Assalamualaikum and a very good morning to all of you. 100 viewer, thank you very much for watching this YouTube live stream for Basic Engineering Static EB025. Okay, today we will discuss about the define and describe the concept of forces here. Explain vector operation, additional, subtraction, and multiplication. Okay, introduction. Okay, in engineering field, mechanics can be defined as a physics of sign. Physics of sign. Mechanics is study of how force act on a body, whether it is stationary or moving. That means that in engineering, um, if there is force and the force is act on the body, we call it physics, mechanics. The force act on the body. That means the force tolak act on the body, either push or we pull. Okay, so the impact of the forces, the pull or push, either the object is stationary or moving. Okay. Okay, the objective of is to explain the physical phenomenon acting on the body. Okay, phenomenon acting, that means what will happen to the body, rigid body, and it is fundamental application of science in engineering. The basic application of science in engineering. Okay, if you, I remind it again, if you have any question regarding this topic, please chat with me privately, and I will try to answer it. Okay. Okay. Mechanic can divide into 3 branches. Okay, mechanic, not a mechanic repairing car. Mechanic mean mechanic. 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 The robot is mechanic. Robot can move. Mechanic. Rigid body, static and dynamic. Static. Static mean stay at one place, not move. Static. On in rigid body in bahasa Melayu, we call it jasad tegar. And dynamic mean move. If you pull the object and it move, we call it dynamic, move. Static means stay at one place, not move. Okay. Deformable body. So deformable body, mechanic of material. Badan boleh ubah bentuk in Malay. I mean if we crush a span, if we crush the handphone, this handphone, crash it, and then the handphone broke down. Okay, that means can be deformable body. That means we can change the physical of the object. Okay, fluid. Fluid mean cecair in Malay. Fluid, like a river, the river flow, we call it fluid. Okay. Okay, but we only discuss about in this chapter. We discuss about the static. That means the body is static and dynamic. The body can move. Okay, static. Deal with equilibrium of body at the rest and move with constant velocity. That means if we pull the body and then the object, and then the object move with constant velocity. That means constant velocity is the same speed, constant velocity. For example, we push it 1 mile per second. That means they push it 1 mile, no more than 1 mile per second. Okay. Dynamic, deal with acceleration of motion of the body, speed. Not a dynamic, we deal with speed, speed, not a constant velocity, laju malah. Okay. If you have any question, you can chat with me privately. Okay. All right. Another slide. Force. Okay. Force is an action of trying to change the original position of original body. Okay. We push. We push the object. Okay. The symbol of force is F, and it units in Newton. Okay. Okay. Forces. is called coplanar when acting at the same plane. That means acting at the same plane. That means it acting on the same plane. This is a plane. Acting on the same plane. They're not out of the plane. Okay, acting on the coplanar. If it's called concurrent, if concurrent acting at the same time, that means like this one, acting at the same time and at the same point. At the same time, at the same point. Okay, they're acting. For example, and when the bomb is dropped and then the bomb explodes. Explode is meletup. Then the bomb that we call concurrent, acting at the same same point and at the same time. Boom. Meletup. Okay, blow the bomb. So coplanar is like at the same plane, like this plane. Okay. So F we call it unit. So if you have any question regarding this topic, you can directly ask me by chat. Okay. Right. So I go to another slide. Concept of forces. Okay, vector quantity has both a magnitude and direction. Magnitude and direction. Magnitude is the value. Direction is the way the force is go. Okay, represent graphically by a line drawn to scale in the direction of line of action of force. Okay, in the line. Okay, represent graphically. Okay, graphically ini represent by graphic. If you graphic in a piece of paper, you draw a graphic. A piece of paper, you draw a graphic. Okay. Okay. Line of action. Represent by arrow. Arrow ni anak panah. Arrow. Okay, where the sides indicate magnitude and the point indicate the direction. Okay. This is the example of this. Okay. Vector. This is vector. Vector A. Line of action. The vector have a value. They have a direction. Direction go there. Go here. Degree. They have a degree. Direction. We go here. And we go there. Okay. The direction. And they have a value. Okay. Okay, vector quantity, concept of forces. Okay, Newton law of motion. Okay, the basic of law of motion of body is based on the population introduced by scientist Sir Isaac Newton in the middle of 17th century. Okay, if you are dealing with physics, if you are dealing with engineering, you know who's Newton. Okay, Isaac Newton formulated three basic laws of how body can be stationary state or in motion, which is known as the Newton law of motion. Okay, Newton law of motion. Okay, Newton law of motion. They have three type of law. First, second, and third. Okay, Newton law of motion. Okay, Newton law of motion, Newton first law. Okay, what is the Newton first law? An object at rest tend to stay at rest. Okay, an object at rest tend to stay at rest. That means that an object is not move, the object not move, and then they stay. An object in motion tends to stay in motion with the same speed. Okay, an object and in motion tend to stay in motion. Okay, stay in motion, same speed and same direction, unless acted upon by unviolent force. This is the example. Okay, the object is rest body, stay, the object stay, and then the body move at the constant velocity. Okay, Newton first law. Okay. Okay. Okay, explanation. Okay. Explanation. A natural tendency of object to keep on doing what they are doing. All changes, all object resist. It means that the object is have a tendency to keep on doing what they are doing. Okay. For example, the object it's not move. So for example, we want to push the car. The object resist chain in their state of motion. Okay, they resist. They try to hold. The object try to hold the car, not to move. Okay. In the absence of unbalanced force, an object in motion will maintain instead of motion. So the formula is F equal to 0. So in the beginning, the object is F equal to 0, not move. Okay, not move. But if they have acting, they have act on the object, and then suddenly the object will move. We call it acting force. Okay. Okay. Next slide. But they have another Newton law of motion, Newton's second law. Newton's second law, the acceleration of body in the same direction and in the same direction is proportional to the force acting on it. Okay, F is A. Okay, that means the speed of the body is in the same direction. Is proportional. So it's proportional mean the acceleration of the body in the same direction is the same direction, and is in the same direction is proportional to the force acting. So if the force is very big force, very hard force, so they will move the car will move faster. If we put less force on the car will move slower. Okay, that we call it Newton's second law. Explanation: acceleration is produced when a force acts on a mass. Mass means the object. Yeah. Acceleration, pecutan. The speed, not the speed. The speed. Another word, acceleration is speed. Velocity is different. Okay, the greater the mass of the object being accelerated, the greater amount of force. Okay, that means if you want to push the very big car, the greater the mass, the greater the weight, the greater the car, the big the car. For example, you want to push the lorry, so you need more force. You want to push the lorry, you need more force. Compare if you want to move a small car, Viva. You don't need a greater force. Okay, so that means, for example, that's why the lorry usually use a very big machine, big engine compared to Asia. Asia, you can use 800 cc. The lorry usually 3000 cc. Asia 800 cc. Okay. Lorry usually 5,000 cc. Okay, lorry 5,000 cc. Asia is 900 cc. Yeah. When I was in the university, I used Kancil 850 cc. So, but still the speed is very the car is very faster because the weight is very light. The weight is very light. Last night I went to Alusta. Okay. Okay. Oh, sorry. I have comment. Okay. Oh, I don't see the comment. Thank you very much. Thank you very much, Mr. Fidos. Okay. I see the comment. Okay. Right. Okay. Okay. Assalamualaikum. Okay. Thank you very much. Waalaikumsalam warahmatullah. All right. Thank you very much. Okay. Okay. If you have a question, you can put down. I just read the comment. Thank you very much. So the greater the mass, that means the weight of the car is very more weight. So we need a greater amount of forces. Okay, input. Okay, for example, lorry and my. Okay, so F is equal to MA. Force equal to MA. Force is acting force. M is mass. A is acceleration. Newton. Okay. So okay, next slide. Okay. Okay. Newton third law. Okay. Newton law. Each acting force will have an opposite reaction, force of equal magnitude. What is this? You see this? This is a car. With the rocket propeller here. Okay. Right. Explanation. Two objects is in contact with one another, and moving must use the reaction law. Okay. That means for every action there is an equal and opposite reaction. Okay. FA equal to negative FB. That means if you have a action, there must be another reacting reaction. If you want to push the object, and then they must have a reacting. That means the opposition object regarding this push. Okay. Okay. Go to another vector operation. Okay. Okay. Vector is an object. Like I explained it before. Vector. What is the vector? We already explained it. I already explained it. What is vector? Vector is an object that have a magnitude and direction. You have magnitude and direction. That means you have a value and the direction. The direction in the way they want to go. Direction. You want to go to north, south, east, west. It represented by arrow. Okay. Size indicate the magnitude. The size of the arrow. No, the size of this one. The size of line. Point indicate the direction. Direction. Okay, this is the magnitude. You can find the magnitude if you draw using the graph paper or whatever. You use the scalar. Geometrically, a vector can picture as directed line. Okay, segment whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of the vector is from its tail to the head. From its tail to the head. From its tail to the it. Okay. 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 Geometrically, a vector can. Okay. Vector is an object. Okay. All right. Vector additional force. Force acting in the same direction and having the same line of action. The single force having the same effect on the other. That means this one, Okay. F2, F1. They have two force. So the value of total force is F1, force F1 and F2 acting at the point P. Have exactly the same effect on point P. So F1 plus F2. So the sum of the force is F1 plus F2. Okay, for example, if you pull, if you push the car, by 1%, the force is uh, the force is different. If you push the car by 2%, you push 2%, push the car 2%, and then the greater force. If you push the car with 1%, 1% push the car is the force is small. Compare if you push the car, if 2% push the car, okay. So when I was in the university, I used mini minor. My car always broke down. So every time they have a problem, my friend will push my car to start the engine. I still remember it in my university time. Okay. Okay. To start the engine, regulator, to make the regulator run. So if you push one person push, and then 1% in the car. Okay. All right. Vector additional forces. That we call vector additional forces. Okay. The forces acting in the opposite direction along the same line of action. The resultant force is arithmetic difference between the two forces. Oh, so that means yeah, okay. One forces here, one forces pull the handphone here, another person pull my iPhone 7 here, and then so F2 minus F1. You want to know what is the total forces? F2 because the force must have a direction. Okay. Forces of F1 and F2 acting at the point have exactly the same point effect on point P. That means okay, F2 minus F1. Okay, here. Okay, F equal to F2 minus F1. Point. Someone tarik, pull here, push here. Okay. Additional force. Okay, when two forces do not have the same line, this one have a same line. Okay, when two forces do not have the same line of action, the magnitude and the direction resultant may be found by a procedure called vector additional force. They have this what we call this concurrent. Concurrent at the same point, we call it concurrent, F1 and F2. So the resultant force here, the resultant force F1, F2, this one, F1 plus F2 in the vector. Okay, the above resultant force can be determined by two methods, parallelogram and trigonometric method, coplanar forces method. Okay. Okay, next. Okay, vector additional. Okay. This one is called parallelogram law. Okay. Here is A, this one is B, and then this is the resultant. the resultant force A plus B. They have magnitude. Don't forget, vector have a magnitude and direction. Okay. Okay, the result can be found by triangle construction. If you want to make a triangle, also can R plus equal to A plus B. Okay, A, B, and then this one. Vector A and B are collinear. Collinear mean have the same line of action. R equal to A plus B. So vector subtraction. Vector subtraction. Okay. Special case of additional. R equal to A minus B equal to A plus minus B. Rule of additional applies. So what do it mean? This A, this minus B, this R. Okay, R. A, B. Okay, R. Parallelogram triangle construction. Okay, this is the most important. Vector multiplication. Vector multiplication. Technique of the multiplication of two or more vector with themselves. They have two types of vector multiplication. Dot product, or another name is scalar product. A dot product A dot B equal to A dot B equal to A, this is magnitude, B magnitude cos theta. If cross product, or another name is vector product A cross B equal to A cross B sin theta. Okay, vector multiplication. Okay, scalar product. Okay, vector product, scalar product or dot product. A is the modulus or magnitude of A. B is the modulus of B, and theta is the angle between A and B. This one, theta is the angle between A and B. Okay, theta. Okay. Okay. B cos theta. B cos theta, that means this one is B cos theta. That's why we get A dot B equal to AB cos theta. That means A times B cos theta. B, this one B. B times theta. This one B sin theta. B sin theta. This one B cos theta. Okay? A dot B. So, okay. Example. Okay, we go to example. Okay. Consider the two vector A and B shown in figure 2. Suppose has A has 4 unit. Okay. This A has 4 unit. B has 5 unit. Okay. The angle between them is 60 degree. The angle is 60 degree. Okay. Figure 2. This one is figure 2. A and B have the length 4 and 5 unit respectively. Okay. The angle between is 60 degree. Okay. We can use the definition above to find the scalar product. Okay, we want to discuss about the scalar product. Okay, what is A dot B equal to A times B cos theta. B cos theta. If A is here, A cos theta. 4 times 5 times cos theta. So you get the answer 10. Okay. The answer is in a scalar. Scalar means magnitude. They don't have direction. Okay. The answer is in scalar. Scalar is magnitude. Scalar is magnitude. Non-vector is have a magnitude and direction. You must know that. Okay. Right. Next. Okay. commutatively and distribution. Suppose two vector. In the previous example, we calculate in the different order. That is suppose what we want to find. So here we want to show if B dot A, what is the answer? The answer is different, is the same. Yeah. Okay, B 4 times 5 times 4 cos theta. Get the same answer. That means A dot B equal to B dot A. Okay. Okay, commutativity. Okay, for the two particular vector, A dot B is equal to 0. Why? If the for two perpendicular, that means perpendicular vector 90 degree. Perpendicular means 90 degree. Okay. Okay, this is the example. Okay. Consider the two vector A and B shown in figure 3. The angle between them is 90 degrees as shown. A times B. The angle between A and B is 90 degree. So I want to show you why if the two perpendicular vector A dot B is equal to 0 here. Okay? A dot B equal to A, B cos theta. A, B cos 90. Cos 90 means 0. So the answer is 0. Because cos 90 is 0, the true whatever the length A and B, so the scalar product of the two vector at a right angle is always 0. We say that that such vector are perpendicular or orthogonal. Okay? Orthogonal, orthogonal. Alright. Okay. Okay. If IJK ni X, Y, Z are unit vector in the same direction of X, Y, Z. I dot J equal to 0. I dot K, this one is 3D, 3 dimension. IJK. That one we showed, I showed it before this, 2 direction, I and J. I dot J, I dot K, so J dot K. Okay, I want to show you later. J dot J, K dot K, okay? Right? Okay. We now consider how to find the scalar product of two vectors when these vectors are given. Okay, A, okay, this one in the coordinate, they give the coordinate, okay? B, we give the coordinate. I, J, K are unit vector directly X, Y, and Z respectively. First of all, we need to develop the result, okay? Therefore, we want to find I dot J, okay? We want to, this vector are shown in figure. Not because I and J lie on the along the X, Y axis, they must be perpendicular. From the result, we have established the scalar I dot J must be 0. For the same reason, we obtain the same result if we calculate I, J, K. Okay, so I want to show you I dot K is 0, okay? Actually, this one, I dot J. I dot J cos 90. Cos 90 is 0, okay? I dot K cos 90. Cos 90 is 0. K dot J. And so cos 90 is 0. So cos 90. I dot I. That means cos 0. Cos 0 is 1. Okay? We get the answer is 1. Okay? Okay. Since cos theta is cos 0 is 1, J dot J is 1, K dot K is 1. Okay, dot product. Okay, example. Okay, example. Suppose we wish to find the scalar product of two vectors. A 4i times plus 3j times 7k, and B 2i plus 5j plus 4k. Okay. The result we have derived tell us multiply the I component together, multiply the J component together, multiply the K component together, and finally add the result. So A dot B. Okay, do you want to find A dot B? This one is A in the coordinate. Okay, coordinate. This one is B. They have coordinate. Okay. A is 1,4 times 2 from B. Okay, I want to show you how coordinate. Okay, 3 times 5. 3 times 5. 7 times 4. So 8. So the answer is you don't need to have a cos theta because they don't give you a theta, the angle. If they give you the coordinate A dot B, you don't need to multiply by cos theta. Okay. Okay. Suppose we wish to find the scalar product. Yeah. Okay. Same. Two vector. Two vector same. They are so this example do not have a J. Okay. A is minus 6i plus 3j minus 11k. B equal to 12i plus 4k. So A dot B 6 times 12 plus 3 times 0 because J, they don't have a J. Plus negative 4 minus 4. Negative 11 minus times 4. So the answer is that is. So okay. Okay. This one is so this is the formula. A dot B A1 B1 plus A2 B2 plus A3 B3. Okay. This is a okay. Same. Okay, same. A times 2, 4 times 2, 3 times 5, 7 times 4. Okay, this one. Okay. All right. Okay. But okay. If you want to find the angle, how we want to find the angle between A and B? We want to find the angle. Okay. How we want to find the angle? Okay. So A and B can be found from the cos theta. So A dot B, A magnitude of A, okay, time magnitude of B. Okay, we want to find the angle. Okay. Alright. Okay. If you want to find the angle, first we need to to convert the coordinate to the magnitude. The coordinate to convert this coordinate to the magnitude. How we want to convert the coordinate to magnitude? We make this one. 4 squared plus 3 squared plus 7 squared. Okay. You get 74. Okay. Square root of 74. You square root this. And then for B, this is magnitude of B. How we want to find the magnitude of B? 2 squared plus 5 squared plus 4 squared. We square root of this. So cos theta equal to A dot B divided by A magnitude of A and magnitude of B. So this is you get the answer, and then you using the calculator you get the degree. Okay. This is the product. All right. Okay. Vector product. Cross product. Cross product is where n is a unit vector in direction of perpendicular. Okay. To get A cross B, use by the right hand rule. Okay. This left. I used to wear my watch in the left. Okay. This is right. Okay. Right. Okay. Make a set of direction with your right finger, thumb, and point your first finger long B, making the smallest possible angle. The direction of the middle finger give the direction of A cross B. All right. The 3 dimension, there is second kind of the product between two vectors that do not have. Okay, the C is the product of A cross B equal to C. C is defined to have a magnitude. Okay. Where the angle between A and B lies on the 0 and 180. Okay. The cross product of C is defined to be perpendicular. Okay. to the plane containing A and B, and its direction is defined as follows. If the first vector listed is rotating through the angle alpha so that the direction coincides with that of B, then the point C directed is in the direction that ordinary screw thread will move this. Okay, for example, okay, A cross B. Okay, this is the C. C. A, okay, A cross B. Okay, A cross B. So the direction is up. Okay, A cross B. All right, A cross B. Okay, so okay, this one is clear. You can see the thumb of right hand point in the direction of the first vector and the index point in the direction of the second vector. The middle finger can point in the direction of the correct. Okay, A cross B. This is the answer. A cross B. This is the answer. C is equal to A cross B. Vector product is not a commutative, mean that if the order of the product is switched, the different vector. Okay, the vector product is the negative of the vector product. Vector product is the negative of the. If we have a different, the answer is different. If A and B are parallel, vector product is 0. Okay, if parallel A and B parallel, the cross product is 0. Okay. Okay. Where is the null vector? Null vector, 0 magnitude, no particular direction. So easier if you want to. If the two vectors are perpendicular to each, the magnitude of the cross product is equal to the product of their magnitude. Since the sign of 90, sin 90 is equal to unity. To express the cross product in terms of component, we can use the definition. A cross B equal to magnitude of A times B. If A and B is perpendicular, because sin 90 is 1. Okay, sin 90. Okay, okay. So we can see it. 1 cross I cross J. I cross J. The answer is K. Up. You go to up. We go up. Okay. J times K. J times K. Counterclockwise. J times K. So the answer is I. Okay. J times K. K times I. K times I. K cross I. The answer is J. Okay, the J. Counterclockwise. Okay, this is clockwise. If J cross I, J cross I, the answer is minus K. K cross J. Okay, if you follow the clockwise, the answer is here, minus K. Minus I here. Okay. I cross K. The answer is minus J here. Okay. Okay. I cross I is equal to J cross J equal to K cross K is 0 because sin 0 is 0. Kalau if dot product I cross I dot I is equal to 1 because cos 0 is 1. Okay. Right. Okay, we calculate this one. This is call it metric. Vector 347 492. Okay. 347. Okay, 347 492. You want to make a cross product? Okay, 3 we close this one for 8. Okay, 4 times 2 7 times 9. Okay, minus. Okay, minus minus. If two cross product, minus. Okay, minus and plus. Okay, we close this one. 3 cross 2 times 2, 7, 4 times 7. Okay, the minus. Okay, plus. For k free coordinate, we close this one. 3 times 9 minus 4 times 4. Okay, we get the answer. All right. Okay. Okay, we get the answer. So same thing. The question same. Happen like this. Same. 430 Okay, 430 I for I. Okay, 3 times 0, 0. 0 times 0, 0. Okay, for J, 4 times 0, 2 times 0. For K, you have the magnitude. Okay, K, 4 times 0, 2 times 0. So you get this. Okay, for A, we want to find the magnitude of A. Okay, we get the 5. So by this one, Okay. Okay. So this is the summation of the vector product.